Far beyond our solar system, locked in a scorching orbit around a distant star, lies a planet unlike any we have ever seen. Its surface reaches thousands of degrees, its year lasts less than a single Earth day, and its bizarre nature defies expectations. This is 55 Cancri E, also known as Jensen, a world so extreme it's rewriting what we thought planets could be. In this video, we will explore how scientists discovered this fiery exoplanet, what we have learned about its star system, and why it continues to captivate astronomers around the world. You are watching Planet Spiral. I'm Natalie, your host. If you enjoy cosmic mysteries and space science, be sure to like this video and subscribe to the channel. On a dark, clear night, in the constellation of Cancer, you can actually spot star 55 Cancri A with a naked eye. It's a brighter component of a binary system, paired with a much fainter red dwarf companion, 55 Cancri B. Separated by about 6 light days, the two stars are distant enough that their respective planetary systems remain gravitationally undisturbed. 55 Cancri A is a G-type star, similar to our Sun but slightly smaller and dimmer. It's home to at least 5 known planets, named by their discovery order B, C, D, E, and F, and possibly more yet to be discovered. These planets have also been given names honoring pioneers in astronomy: Galileo, Brahe, Lippershey, Harriot, and our focus today, Jensen, named after Zacharias Jensen, the Dutch spectacle maker credited with inventing the compound microscope. Jensen is the innermost planet in the system, orbiting so closely to its star that it completed a full revolution in just less than 18 hours. It was discovered in 2004 using the radial velocity method, which detects small wobbles in a star's motion caused by orbiting planets, initially thought to have a longer orbit. More refined data from telescopes like Spitzer revealed the planet's ultra-short blistering paths, just one of the many surprises Jensen had in store. Jensen orbits so close to its host star that astronomers often say it's practically inside the star. Not literally, of course, but it skims just 0.015 astronomical units from the stellar surface. 1 astronomical unit, or AU, is the average distance between Earth and the Sun, about 150 million kilometers, or 93 million miles. Jensen, by contrast, orbits at just 1.5 million kilometers from its star, about 65 times closer than Earth is to the Sun. At such a blistering distance, Jensen brushes the outer layers of its star's photosphere, the glowing surface we see when we look at a star like the Sun. From the planet's surface, the star would appear nearly 70 times wider than our Sun does from Earth. It would stretch across the sky like a searing wall of fire, bathing the planet in constant, unrelenting light and heat. Jensen exists at the very edge of what we define as a planet-safe orbit, where the difference between a world and a star starts to blur. While Jensen's sky is dominated by the blinding glare of its host star, from its night side, Cancri A's companion star, 55 Cancri B, would appear as faint, reddish speck in the sky, no brighter than the dimmest stars we see from Earth. On the blazing day side, however, it would vanish entirely, drowned by the intense glare of 55 Cancri A. 55 Cancri A is believed to be a 4th-generation star, meaning it formed from the enriched remains of multiple generations of previous stars. Each generation of stars produces heavier elements through fusion and supernova explosions, seeding the next generation with the materials needed to build planets. Our own sun is thought to be a third generation star, but 55 Cancri A goes one step further. As a result, it has a higher concentration of metals. Astronomers call this high metallicity, which makes the formation of rocky, Earth-like planets more likely. And with an estimated age of 8.6 billion years, it's nearly twice as old as our 4.6 billion year old Sun. That means planets like Jensen have had billions more years to evolve or be reshaped by cosmic forces. Jensen is a classic super-Earth, about twice the size of Earth, but nearly 8 times more massive. That high density points to a compact, rocky world with a massive metal-rich core likely composed of iron and other heavy elements. This dense core may make up more than half the planet's mass, surrounded by a silicate mantle under extreme pressure and temperature. Given its proximity to the star, parts of the interior could be molten, driving powerful volcanic activity that may still shape the surface and even contribute to its atmosphere. Early on, 55 Cancri E was dubbed the Diamond Planet. Based on the high carbon-to-oxygen ratio in its host star, some models suggested that the planet's interior could include vast quantities of carbon, possibly even diamond. It made headlines, but newer data painted a more Earth-like picture, rocky, molten, and violently active. While diamond could theoretically form deep within its interior, the surface is far too hot for such materials to survive, let alone erupt. Still, this idea captured imaginations and showed how much our understanding of exoplanets can evolve. One of Jensen's most fascinating features is that it's likely tidally locked. This means the same side always faces its star, creating a permanent day side and night side. The day side experiences temperatures of over 2400 degrees Celsius, enough to melt rock and possibly sustain vast oceans of lava. Meanwhile, the night side, though cooler, is still scorching by Earth standards, around 1100 to 1300 degrees Celsius. The intense contrast between hemispheres is unlike anything in our solar system. Intriguingly, the hottest point on Jensen is not directly under the star, but offsets, suggesting volcanic activity or even atmospheric circulation at play. For years, scientists debated whether Jensen could even retain an atmosphere. Orbiting so close to its star, the planet is bombarded by intense stellar radiation, powerful enough to strip away lighter gases and gradually erode any atmosphere into space. Under such extreme conditions, many believed Jensen would be left bare with nothing but an exposed molten surface. But new data from the James Webb Space Telescope changed everything. Infrared observations revealed signs of heat redistribution from the day side to the night side, strong evidence for a secondary atmosphere, likely created by continuous volcanic outgassing. This atmosphere probably does not include lightweight gases like hydrogen. Instead, it may contain heavier molecules such as carbon monoxide, carbon dioxide, or even water vapor, elements that can survive longer in extreme conditions. This discovery adds a new layer to the planet's mystery. Despite its hellish environment, Jensen may still be actively reshaping its atmosphere. Could life exist on Jensen? With surface temperatures hot enough to melt rock, constant volcanic activity, and a scorched landscape, it's highly unlikely life as we know it could survive there. But that does not mean it's not worth studying. Jensen helps astronomers put the boundaries of what's possible. It shows us how diverse planets can be and how systems far older than ours might evolve in completely alien ways. 55 Cancri E may not be a diamond world after all, but what it is far more compelling, a molten, volcanic, tightly locked planet sculpted by time and fire, still holding on to secrets we are just beginning to uncover. And as our telescopes grow sharpened and our data richer, Jensen reminds us that the universe is full of strange and spectacular surprises waiting just beyond the light. Thanks for watching Planet Spiral. I'm Natalie. Stay curious, and I will see you in the next one.